Welcome back everyone to Advent of Code Day 12. Today's challenge is called Garden Groups. Today we are in a massive farm and we are still looking for the chief historian. The historians are eating something and looking for the chief since there's a lot of food in this area since it's a farm. And we have a challenge in this farm. There are multiple types of crops being grown here. So in this example, they show you A, B, C, D, E, which are the 5 types of crops being grown, and they're grown in certain regions. So like A is here, B is in this part, C is here, D is there's only one crop for D, and there's E here. We have to find the area and the perimeter for each of these crops. The area is pretty simple. The area is just the number of crops that exist there. The perimeter is calculated like this. So we have this. These are the A crops. Here we have 4 crops, and the perimeter is calculated in such a way that if the adjacent side of a crop is the same type of crop, we don't count that side, but we count the rest of the sides which are not covered by crops, and that becomes the perimeter for that particular crop. So in this case, A has a perimeter of 3. This A has a perimeter of 2, since it is the 2 sides of it have the same type of crop. So instead of having 4 sides, now we are considering only 2 of it to be the perimeter, and so on. So basically we are drawing a box around all the same type of crops. So that's how we find the perimeter. And it's possible that in the farm we have the same type of crop in different regions. Here X is an example of it. We have X in 4 different regions, each of which have an area of 1 and a perimeter of 4. So we have to take that into consideration as well. So our sample input is here. There are quite a few types of crops, and we have to calculate the price for the fence that they want to make around this. And they use a very weird and modern business practice in which we have to multiply the area with the perimeter to get the price of the fence. So here they are showing us how they have calculated the price for the region of our crops. So here it's 12 into 18, so we get 216. Then we have I, but we also have I again, which is in a different region. There's one I group here and there's one I group here. So it's not as simple as I initially thought, because I thought I could just run a double for loop here and then just count the number of crops and find the perimeter for each of them, but it won't work that way. I have another idea. Let's see if that works. Alright, I think after a lot of silly mistakes, I've finally come to this point where I am getting some answer, which is as per the sample inputs answer as well. So let me explain the code. So we are processing the input, which is pretty simple. It's just new line character. We are splitting it by that, and then each character is being split in that to form a 2D array. Since we have it in this way, where we are separating each of the lines and then each of the characters within that. Okay, so after that we are finding the regions. In the find regions method, I'm using DFS to find each individual region. So that uses this find region method, in which I am keeping track of visited nodes and adding regions to an array, which is also a set so that we don't duplicate by some chance. So this is find region. What we are doing here is, if we go beyond the bounds, then we will return whatever region we have found so far. If we see that the crop which we are currently looking at is not the same crop as what we were initially looking for, then we return the region. And finally, if we have already visited this crop, then we return the region, because then going beyond it is of no use. If not, then we add it to the visited and the we add it to the visited and to our current region. We visited, so we are keeping track of it so that even in the future for any other crop types, we don't come into this. And then for the region, we are checking under it, over it, and to its right and to its left, and repeating the same process, and then finally returning whatever region we found, which we add to this regions list. After that, we are finding the total price for each of the regions that we found before. We are keeping track of the parameter, and the area is just the size of it. Then we are converting this set to an array so that it's easier to iterate over it. And then for each of them, we are checking if in this region we have a crop which is of the same type below this and above this, and then to its right and to its left. If it does have something, then we will skip it. But if it doesn't have something, then we will add a parameter part. So as you remember, if something has, like if a crop has the same type on its right, then it doesn't have a parameter on the right. But if it doesn't have something on the left, that means it has a parameter on the left. That's how we are calculating it. I mean, you can draw the box side on the sides where you don't see a crop type. Okay, that made it more confusing. So it's like that. Then just listen to the first part. Okay, so we're getting this 1930 as per the sample input. Now let's try with the actual input. Okay, now before I forget to share my screen again, let's try this. Alright, so we got our first gold star. Let's see what the second part of the challenge holds for us. Okay, so in this part, what we are seeing is that instead of looking at the parameter which we were counting for each of the crops, they want to look at the number of sides. So if we have A is like in a straight line, so it'll have 4 sides, which is the left, top, right, and bottom. Similarly, B will have 4 sides, left, top, right, and bottom. But C will have 1 side on top of it, 2 on the left, 3 on the right, then again 1 on the bottom, which makes it 4. Then the top part of this C, right part of this C, then the bottom part of this, and the left part of this. So that makes it 8. So let me see if I can draw this and explain it. So what we are seeing here is, and then I'll just fill the rest up with some dummy stuff so that it's easier for us to. Now what they want us to do is, these were the A's. This is the one side, second side, third side, fourth side. This is whatever we saw in the last. It's like this. So this becomes 1, 2, 3, 4, 5, 6, 7, 8. So this is quite challenging. I'm thinking about how I'm supposed to do this, but let's see. Okay, I'm back with a lot of messy code. We've not changed much in the starting parts. These are all the same, but we have to, when we find all the regions, and then when we have to find the total price, what we are doing is we are finding the area and sides. So the area is quite simple, we just find the number. But for the sides, we're checking for each region. We are making a dictionary of the sides, and we are checking which side the perimeter is facing, up, down, left or right, and we are adding the perimeters. After that, for each of the sides, we are checking if it's facing up, if there are any other continuous up facing parameters. If so, we will remove them. This part is kind of messy because I'm keeping track of them in a set, and then I'm converting it to an array to keep track of the parts here. And then what I'm trying to do here is I'm just sorting it so that I can check from the leftmost to the rightmost or the topmost to the bottommost. And if I find that there are continuous ones, I'll remove all of them except for one. So let me show that to you here. So suppose we have something like, and then we'll have parameters like this. So if this prop doesn't have anything on top, you're going to make this up facing. Similarly, if it doesn't have something on the right, it will be right facing. This will be left facing. So now what we are doing is we're checking from this. We're checking if this has a parameter on the right. If it has a parameter on the right, we'll remove this. Similarly for this, we'll remove this, then we'll remove this. We'll finally have this left. which will mean this is one side. Similarly, we'll remove this. This means we have two sides. And then since here there is nothing else on the bottom, we have three sides for this. And similarly, these things will also have something here. Not this. So this will get cancelled. It'll have one. So it's like this. So it'll have this direction, this direction, this direction, this direction. So we'll get it like this: 1, 2, 3, 4, 5, 6 sides. Similarly for this, we'll get 4 sides by cancellation of parameter. That is kind of dirty, but this is one solution I could think of. We're getting our output as per the sample input. Now let's try it for the actual input. Sort of slow because of how many things I've made a mess of there. Great. I'm not very proud of today's solution though. I have to see if there is any other way to do this. But anyway, let's see you on day 13. I think things are getting challenging with every day now. Alright, see ya then. Bye.